Hi, welcome to this session. In this session, we're going to do binary operations. So, I have these questions which were asked in exam Math 1100 and also for Math 1120. The first question was, let star be the binary operation on the set of real numbers defined by that. Determine whether the binary operation is commutative. The second question was, using the operation star defined by that, evaluate that. Okay, before we can answer these questions, let's try to understand binary operations so that we'll get back to them and it will be very easy for us to tackle now these questions. Okay, I'll go to the other slide. So I have those questions, but let's try to understand binary operation even before we can tackle these questions. Okay. So what is binary operation? What is a binary operation? So a binary operation is an operation that deals with only two things, okay? Bi means two. When you're talking about a binary digit, it just deals with 0 and 1 digits which are just zeros and ones, okay? Those are binary digits. So same applies to a binary operation. It just operates on two things, or it's an operation that deals with only two things, okay? So we're saying a binary operation deals with two things, okay? So that is what you need to understand there. So let's say we have A star B. So a binary operation usually is indicated by a star symbol, okay? So this is an operation that is used for binary, okay? Then let's try to understand these operations: addition, multiplication, division, and subtraction, if they are binary, okay? So for addition, let's try to understand. Let's set A be equal to maybe 0 and 1. So let's understand if addition is a binary operation or is commutative on this set A, okay? So we have A is equal to 0, 1. So we'll have a table like this. Need to do a table, then we put 0 there, 1 there, even this side 0 there, 1. We're trying to see if addition is a binary operation on this set or is commutative rather, okay? So determining two things here: if addition is a binary operation on this set, and also if addition is commutative on this set. So let's add 0 plus 0, that is 0, 0 plus 1, that is 1, 0 plus 0, that is 0 plus 1, that is 1, and 1 plus 1, that is 2, okay? So we can see that there is a number which is greater than 2, or which is not part of this set. We've been given 0 and 1, okay? Set A. So you can say that addition is not a binary operation. It is not a binary operation on A, okay? It is not a binary operation on set A, because there is this number which is not part of A, or is not commutative rather. So if we need to see if the two sets are commutative, if we draw them, the leading diagonal, these numbers which are along the leading diagonal must be the same. Okay, they must be the same. I can't say they should be reciprocating, but they must be the same. Okay, let's try to understand if multiplication is a binary operation on the set A. So we had set A, which is 0, 1. Let's have this table. So we'll say 0 there, 1 there, 0, 1. And let's put multiplication. So 0 times 0 is 0. 0 times 1, that is 0. 1 times 0, that is 0. 1 times 1, that is 1. We can see that all the solutions or the results we've gotten are part of set A. So we can say that A is 1. We can see that multiplication, or just say times, is a binary operation on set A, because if we take this as a leading diagonal, we'll see that the numbers along the leading diagonal are just reciprocating. Okay, they're just, in short, they're not even reciprocating, but they're just the same. Like this 0 is just the same as 0 there, that 1 is the same as 1 there, and this 0 the same as 0 there. Okay, and there is no number which is exceeding, or all the values we've gotten, they are within the set which is 0, 1. So multiplication is a binary operation on this set, and they are commutative. Okay, so let's look at commutativity. Let's look at commutativity of a binary operation. Let's look at commutativity of a binary operation. Okay, let's have, let's say, a certain table. Let's say here we have like this. Let's say we have, maybe this is a binary operation. Let's say 1 and 2 and 5. Here also 1, 2. Let me extend this, and 5. Then let's say we have 1 there, 5 there. Then let's say we have 2 there. Then we have 1, 1 there. Then we have maybe 5 here, 5 there. Then we have 2 there, 2 there. So for this to be a binary operation, let's see. We said that if we take this to be a leading diagonal, the numbers at the adjacent point must be the same. So let's check. You can see that 1 is equal to 1, the adjacent. Even there 2 is the 2 there. Even there 5, or we take 1 and 1, they are adjacent, they are just the same. Then here, if we take 2 and this 2, it's just the same. So we can see that this is commutative. So the star, or the binary operation, is commutative on this table. Okay, now let's understand if addition is commutative or not. So for it to be commutative, commutativity law state that when you have a binary operation star b, it should be equal to b star a. Let's have an example. Let's say we have 2 plus 3. Is 2 plus 3 equal to 3 plus 2? So if it is equal, we're going to say it is indeed commutative. So 2 plus 3, that is 5, is equal to 3 plus 2, that is equal to 5. So we can conclude that addition is commutative. Okay, so addition is commutative. Let's look at multiplication. So for multiplication, if we have a by times b, it should be equal to b times a. For addition, we said if we have a plus b, it should equal to b plus a. So basically for multiplication, if you have a times b, it should be equal to b times a. So let's have maybe 3 times 5. Is 3 times 5 equal to 5 times 3? 3 times 5, that is 15. It is equal to 5 times 3, that is 15. So you can say that multiplication is commutative. Okay? Let's look at subtraction. 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 If we have a minus b, it should be equal to b minus a. Let's have 2 minus 1. Is it equal to 1 minus 2? So 2 minus 1, that is 1. 1 minus 2, that is negative 1. We can say that 1 is not equal to negative 1. So we can say subtraction is not commutative. Okay, so subtraction is not commutative. Let's look at division. With division, if you have a over b, it should be equal to b over a. Let's have an example. Let's say 2 over 1. Is it equal to 1 over 2? No. 2 over 1 is simply 2. It is not equal to half. This is not equal. So we can say that division is not commutative. Okay? Division is not commutative. So that's the conclusion. So now, after understanding that concept, let's have an example. Let's have an example. Let's say let star be the binary operation for a star b to be equal to, let's say, 3ab. Okay, let me now use ab again. 3x y. Show that the operation is commutative. So how can we show? So we have, this is our working. Okay, we have a star b to be equal to 3xy. So for this to be commutative, we say a star b must be equal to b star a. Okay, so a star b must be equal to b star a. So what it simply means that a is symbolizing x, okay, the first value there, and b is symbolizing y. So if we have a is equal to x and b is equal to y, let's substitute this. So we are going to say b star a will be equal to 3. We will start with their x, it was a, so we interchange now, it will be y. Then y is equal to b. Okay, b is equal to y and x is equal to a. So we will interchange this, so there will be x there. Okay, so we have b star a is equal to 3xy, and we can write this as b star a is equal to 3. We said multiplication is commutative, so it will be same as writing 3xy, and therefore we can see that a star b is equal to b star a, so this is commutative. Okay, so what if you were given a question to say, given star is an operation on maybe a star b to be equal to 3 plus not this, maybe a plus let's say ab plus b. Then they tell you to evaluate, let's say 2 star 3. How can you evaluate this question? So you get this value a star b is equal to ab plus b. Okay, remember we are evaluating 2 star 3. So what it simply means here, we just compare 2 star 3. It means that a is 2 and b is simply 3. That's the meaning there. So this is what it means. So we're going to say 2 star 3 will be equal to, where there is a, we'll substitute what? We'll substitute 2. Where there is b, we'll substitute 3. Then plus b is simply 3. So 2 star 3 is equal to 2 times 3, that is 6, plus 3. And 2 star 3 will be equal to 6 plus 3, that is simply 9. So that is how you can evaluate. Okay, so basically that. Let's look at, we've tackled the commutative law. Now let's look at associative law, or law of associative. Law of associative. Okay, for associative we can have an operation, let's say a star b in brackets star c. This should be equal to a star, we can start with b, what is in brackets, like you can start with b and c, then we go back to a, or we can start with a star b, then we go back to c. So this is the law of associative. Okay, so let's have an example. Let's say we have show that star is associative on a star b is equal to a plus b minus a b. We want to show that star, the binary star, is associative on this. Okay, on this operation. Okay, so how can we show that this star is associative or it is not associative on this binary operation. Okay, so how can we show? Or to make it interesting, let's use 3 letters, since most of the times associative is shown with 3 letters. It's written like this. Okay, then one will be in bracket, then is equal to, let's say, A plus B, like that, then plus C. Okay, let's show this. So we are going to say A star B star C, so like this, is equal to let's say it was A plus B, is like that, plus C. Okay, so to show that this is associative, we are going to say A star B in bracket like that star C, it should be equal to A star B star C. Now let's see if this is equal. So we can say that this is equal to A plus B plus C, and we can see that this is simply equal to that. We said addition is commutative. Okay, so therefore this operation star is associative. It is associative on that operation. Okay, on that operation or on that given mathematical expression. Okay, so basically that is how you can show associativeness and commutativeness of a binary operation. Let's just have another example. Let's say we've been given the binary operation A star B is equal to, let's have AB minus AB minus A. Then we've been given, evaluate A star 2 like that, star 1. So when we've been given such a question, we said a binary operation deals with only 2 things. So we must begin with this, what is in the bracket, then go to what is outside the brackets. Okay, so that is what you basically do. So we're going to begin with this 3 and 2, then we'll go back to that. So we're going to say this will be equal to, we'll start with 3. 3 is representing A, so we're going to say 3, then B is being represented by 2 there. Okay, 2, then minus A is being represented by 3. Then this will put it in brackets like that, then in square brackets, then we say star 1, this one. Okay, we haven't touched anything on this value because a binary operation first to deal with 2 things, then we'll come back to this after we find the value of 3 star 2. Okay, so what we are going to have is 2 times 3, that is 6, minus 3 in brackets like that, then star 1. me up the top part. So I'm going to say 6 minus 3, that is 3, then star 1. Let's now again perform this on the operation we are given. It was a b minus a. Okay, let's now perform again this expression now, or this operation rather. So we're going to, our a will now be 3, then our b will now be 1. So what you're going to have basically is 3, where there's b, we'll substitute 1, minus where there's a, 3. You can see that 3 by 1, that is just 3 minus 3. So we're going to have a 0 as the final answer. So that is what you do there. Okay. So there is also what is known as the identity element. Identity element of a binary operation. So what is it about the identity element of a binary operation? Let's say if you've been given a star e, considering e to be an identity operation, you must have, or what you must get is equal to, you must have this value, which is a star a. Okay, then if you have this final value must be equal to a. That is it about the identity operation. Okay, a certain value star the identity, okay, is simply equal to that same value. So for better understanding, let's and this is for say real numbers. Okay, for real numbers, let's have an example for it to make sense. So let's have addition, adding. Okay, let's say we have 5. Which value can we add to 5 but the answer will still be 5? We can see that 5 plus 0 is what? 5. Okay, let's have, we have 10. Which value can you add to 10 but the final value will still be 10? You can see that it is just 0. So what are we saying? 0 is an identity. 0 is an identity element on addition. Okay, that is what you need to understand. 0 is an identity element on what? On addition. Okay, now let's look at multiplication. For multiplication, we can have, let's say, which value can we multiply with but the answer will still be 4? Which value can you multiply with 4 but the answer will still be 4? So you can say that it's 1. 4 times 1 is just 1. Okay, then let's say you have 6. Which value can you multiply by 6 but the answer will still be 6? It is just 1. So you can say that 1 is a binary, is an, not a binary, sorry, is an identity element. Is an identity element on multiplication. Okay, so basically this is what you need to understand. Now let's have an example. Let's have an example. Let's say you have, let's the binary operation, let's say a star b equal to a plus b minus a b. Okay, then they say find maybe the identity element for this operation. So how can you find the identity element for this operation? We said that if you have a star a binary operation, an identity element, this is equal to just A. So let's perform this operation on these values we've been given. So this will be equal to what? So when you say A star E to represent identity element, this will be equal to A, okay, A plus A, then minus AE, okay. So to make it even more interesting, let's say we find the identity element for, let's say, addition, okay. If we add these two, let's find the identity element. So we can say that we can actually perform something here. We can say A plus, let's factor out A, then we'll remain with 1 there minus A, okay. Now let's say this operation, we take one part. This operation we are performing is on A multiplied by B, okay. Or we say it is on addition rather. Let's use addition. So like that should be equal to